now. So, no current will flow through from anode to cathode if gate is open, if gate is open. But if we increase the voltage, or we can see if we increase the voltage, that is anode to cathode main voltage, that is forward voltage, if we increase this voltage, then a point will come where the junction J2 will break. If we increase the forward voltage, that is voltage across anode and cathode, then a point will come where the junction J2, which was reverse bias, will break, and the current will start flowing from anode to cathode through junction J1, J2 and J3, because J2 is now breakdown. So, the point where this breakdown occur is called forward breakover voltage. So, this point where junction J2 is break is called forward breakover voltage. So, now gate was open, we keep on increasing the voltage. So, when we keep on increasing the voltage, forward voltage, then the point will come where this junction J2 will break. When this junction will break, when this junction J2 will break, the current from anode to cathode will start flowing. So, two case we see when gate open. When gate open, first no current will flow, second case current will flow, but after the forward breakover voltage. So, junction J2 will break after the forward breakover voltage. Okay. So, you can see when forward breakover voltage is achieved, then junction J1, which was already forward bias, current will go pass through the junction J1. J2, which was reverse bias, now break after the forward breakover voltage, and current will cross the junction J2. Junction J3, which was already forward bias, the current will cross through the junction J3 and through the cathode terminal back to the battery. So, from positive terminal battery P N back to the through the cathode back to the cathode terminal back to the negative terminal of the battery. So, next is gate is positive with respect to cathode. So, now second case is gate is positive with respect to cathode. So, when gate is positive, that is we close this switch. If we close this switch as closed, then current will start flowing, positive current will start flowing from the battery to gate terminal. So, when we close this switch, then gate current will start flowing through this gate terminal, and what will happen then when the gate current start flowing, then the value of forward breakover voltage will reduce. That is the point where this junction, the point at which the current from this junction J2 start crossing, the voltage level will decrease when we apply the gate pulse over the gate terminal. So, if we apply the small positive voltage the gate sufficiently forward bias the cathode junction, the device will immediately turn fully on. So, previously when gate was open, the junction J1 and J3 were forward bias, junction J2 was reverse bias. But if we apply the gate pulse, gate supply over the gate terminal, then junction J1, J3 already forward bias, junction J2 will also becomes forward bias. So, current will cross from junction J1 to J2 to J3 and back to the cathode. So, gate current actually what it does, it lower the forward breakover voltage level, it lower down the forward breakover voltage level. Okay. So, next is VI characteristics of SCR. What we have studied so far, now we are drawing in the form of in the graphical form. So, 3 case we have discussed. So, to draw the VI characteristics, first we have to draw this circuit diagram, again same circuit diagram. 3 case can be obtained. First is gate open, second is gate closed and forward bias, and third is reverse biasing. So, 3 case, first is forward bias and gate open, second is forward bias, gate close, and third is reverse bias. So, you can see when this switch S is open, switch S open, then gate current through this terminal will be 0, gate current will be 0. So, the current which will flowing through this thyristor will be very small, and this current is called leakage current. So, this very small current you can see we here we are increasing the forward voltage, but the current increasing very slightly. So, this current is called a leakage current. So, if we keep on changing voltage, forward voltage, then a point will come, this point where the junction J2 will break and SCR will start conducting without the gate supply. So, this is the point where current will start conducting without the gate supply. So, current start flowing at when at the moment forward breakover voltage point achieve, the voltage across thyristor will reduce to minimum value and current will shoot up and increase abruptly. So, here you can see current increase abruptly. So, this is the forward conduction region, this is the current which is flowing from anode to cathode. So, second case is when reverse bias is applied through across the thyristor. When reverse bias is applied, then all the junction junction J1, J2, J3 will be reverse bias, and when all the junction reverse bias, then no current will flow, but small current will flow, that is leakage current, reverse leakage current through this SCR. But again a point will come where the junction, all the junction J1, J2, J3 will destroyed and current will start flowing through the thyristor in the reverse bias condition. So, this is not the area of interest. Reverse the characteristics in the reverse bias condition is not a area of interest. The area of interest is in a forward bias condition. So, first case is thyristor forward bias, gate open. Second case is thyristor reverse bias, and second case is thyristor reverse bias, and third case is thyristor forward bias and gate current is applied. So, when gate current is applied across thyristor, that is when switch is closed, current will start flowing to the gate. So, what happens when the gate current applied to the thyristor? So, you can understand clearly. So, when we close the gate switch switch S, then the current start flowing through the gate terminal. So, here you can see here I have taken 3 cases. First is IG naught, that is gate current at when gate current is 0, that is same condition when gate is open. Second is when gate current is IG1, which is greater than IG naught, and third case is when gate IG2, when gate current is greater than Ig1 and Ig0. So, we will discuss this third case, that is gate is made positive with respect to cathode and thyristor is forward bias. So, in this case what will happen? So, first case is when gate current is 0. When gate current is 0, the SCR will exhibit the same characteristics that it exhibit in the case of gate circuit is open. So, in this case gate current the current will flow, that is leakage current will flow, and the small leakage current will flow through the thyristor, and the junction J2 will break up at the point forward breakover voltage. After this voltage drops and current abruptly increase. So, this is the when gate current is 0, when gate current is 0. So, next is when we increase the gate current, that is gate current has some value. So, now the gate current has Ig1 values Ig1. So, when we apply gate current, then what will happen, this gate current through this thyristor will reduce the reverse biasing of junction J2. So, this gate current will reduce the reverse biasing of junction J2. When this reverse biasing of junction J2 is reduced, then the forward breakover voltage point, the point at which forward breakover voltage occur, will also reduced. So, you can see when we apply the gate current Ig1 which is greater than Ig0. So, this forward breakover voltage point which was previously at this point, now this shift to this point. So, you can see the breakup of junction J2 now will occur at a low voltage as compared to the when the gate current is 0. Now, if we increase the gate current to Ig2, again the point, that is forward breakover voltage point will come at lower level, lower voltage as compared to gate current. So, this breakover voltage point will shift toward the lower voltage as we keeps on increasing the gate current. So, the value of breakover voltage reduces with the increase in gate current. So, actually what we are doing, we are reducing the value of forward breakover voltage. So, by increasing the gate current, we reduce the forward breakover voltage point. So, these are SCR current rating, that is maximum repetitive RMS current rating, conduction angle, that is duration for which SCR is on. So, this is the conduction angle, surge current rating, latching current. So, latching current is a minimum anode current that must flow through the SCR in order for it to stay on initially after gate signal is removed. So, this is the minimum anode current. Latching current is a minimum anode current that must flow through the SCR in order for it to stay on initially after gate signal is removed. And holding current, minimum value of anode current required to maintain SCR in conducting state. So, peak repetitive forward blocking voltage, SCR voltage rating, peak repetitive reverse voltage, non-repetitive peak reverse voltage, DI/DT ratings, DV/DT ratings. So, these are gate parameters. So, next is commutation. So, so far we discussed the introduction of SCR, turn on process of SCR two transistor analogy. Now, there is one process to turn off the SCR also. So, the process of turning off the conducting thyristor when the SCR start conducting. So, the process of turning off the conducting thyristor is called commutation. So, commutation is the process of turning off or connecting thyristors. So, once the SCR start connecting, it loses its control over gate. To make SCR off, some external means are required. Commutation may be applied as current or voltage. So, two types of commutation are we are going to discuss. First is natural commutation and second one is forced commutation. So, natural commutation is applicable to the AC supply and forced commutation is applicable to the DC supply. In AC circuit, as the current passes through an SCR goes through its natural zero, a reverse voltage automatically appear across the SCR and cause it to turn off quickly. So, in natural commutation, during positive here is the AC supply, thyristor and load. So, during positive cycle, thyristor is forward bias. When we apply the gate pulse, this SCR will start conducting. So, after 180 degree angle, negative half cycle will comes, and this SCR will naturally commutate, and the voltage and the current through this thyristor will becomes 0 after this 180 degree 0 crossing. So, after this point the SCR will turn off naturally. And next is forced commutation. In forced commutation, some external means are required to turn off the SCR. So, in forced commutation, DC supply, where DC supply is given to the SCR, we use the forced commutation. So, there are 5 types of commutation: class A, class B, class C and class D. So, this is the application of simple circuit of half wave rectifier. So, you can see we rectify the AC into DC. Thank you. So,